Here we go. James Campbell is the CTO at Superconductive, the company behind the open data quality project you may have heard of. It's called Great Expectations, which he co-founded in 2017. Prior to that, he spent nearly 15 years working across a variety of quantitative and qualitative analytical roles in the U.S. intelligence community. James has studied mathematics and philosophy at Yale, pretty good school, and is passionate about creating tools that help communicate uncertainty and build intuition about complex systems. Well, James, it's great to have you here on the MLOps.community meetup. I'm so excited to learn a few things from you. Let's start the show. It's all
Okay, that
you,
is
man.
absolutely amazing. That is somewhere between my best introduction and my best serenade that I've ever received.
Oh, well, thank you. I appreciate that. So I do cameos in case anybody wants to hire me. No, I'm joking. I don't, but maybe I should.
Absolutely.
Anyway, we've wasted enough time on the silly intros. I know you got a lot to talk about and a lot to say. I'm going to let you have it. I'll hand it over to you. And if anyone has questions while James is talking, feel free to throw them in the chat, throw them in the question and answer, and I will stop him at the opportune moment. All right? So let's hear it.
Awesome.
Let's see it, James.
Thank you so much. Yeah, thanks so much for letting me come. I'm really excited about it. I'm going to share screen here and
Cool.
get that going.
Oh yeah.
So I got this nice alliterative title, which I think is on point with the musical introduction, Durable Data Discovery. And what I want to talk about is the processes around MLOps workflows and like how we can be effective in taking advantage of the relationships we have in order to keep insights that we gain part of our systems for as long as possible. First, just quick introduction. Actually, there's really not much more introduction needed except for to say that, I mean, even since we first or talked most recently and now Superconductive has grown quite a bit. We're now at about 30 people. And so that leads me to just take 1 second for a quick shameless, we are hiring plug. And, you know, we're at this time where it's hard to find amazing people. Actually, it's not hard to find. Amazing people are everywhere. Hard to get them all corralled into the same place. And that makes me want to take this chance to put in a pitch for jobs at Superconductive. Ping me afterwards, come to our website, check it out. Really would love to get to talk to you. Okay, what I want to talk about today, first is sort of motivating the problem that we're going to be talking about, this broad problem of data discovery and how to make it stick. Then I want to talk about what data assets are and batches, because these are concepts that are really central to how users interact with Great Expectations. But what I've found is that they can be a little hard for people to understand, in part because like they're both intuitive, but those terms are used differently in a lot of different contexts. And then we're going to get into the meat of things by talking about profiling, how you can profile or do exploratory data analysis using Great Expectations in a way that keeps the insights that you generate during that process available to you and to your teammates. All right. So firstly, this like motivation of how we're going to handle things. And sorry, I've got dogs going crazy here in my background. I know this is odd timing. One.
No worries, man. I can sing about it if you want, but
No, that's all right. Okay, we're good. So MLOps and DevOps and GitOps and all the opses, I think have a really important central characteristic. Actually, I'll say one of my favorite jokes a friend of mine told me when DevOps first started coming around is like, he's like, DevOps is just the term that business people use to mean ways to make developers run their own infrastructure. There's something to be said there. There's something good about it though, in terms of the way that it helps multiple groups of people, because at the end of the day, multiple groups of people are going to be involved in any of these complex processes, interact through time and so forth. So feedback and workflows that incorporate feedback are really central to MLOps. Kind of premise, really obvious. So then our question is, how do we actually make that work? So I do want to talk for a second more about great expectations. There's this lovely meme about testing, right? Like testing is one of those things where it's extremely valuable. Often people treat it as an afterthought or a cost, but we're at Great Expectations like firmly believers in the notion that testing is really just a way of defining things and interacting with other people, and like many cases with your future self, right? It's a way of capturing information. So for Great Expectations, what we're doing is bringing the concepts of automated testing that have become central in all kinds of software into the world of data. And, it starts off with very simple declarative statements. Like, I expect that there should be this column in a data set. It's interesting. Since I'm in this venue, I don't know that I've ever actually seen somebody ask for this particular expectation, but having myself been guilty during rapid model development of this problem, I'll say, I wonder if, we probably need to add a expect column not to exist, where that column is, the truth value that you're going to be training against, as part of your feature set. But you start off and there's these like very schema oriented expectations that you can add, and then we also make it possible to sort of look into the data a little bit, look at characteristics of values, like they shouldn't be null, or even across values, like they should be unique. And then even to have some sort of some important semantic characteristics of the data, like values need to be in a range, they need to match a regex or a date time format, aggregate statistics about data, and in some cases, even more distributional statistics about data, right? Things that really capture the essence of what the data that we're working with looks like, and kind of the way that we see it. So the broad framework of these expectations gets applied, I think, with four really, really important characteristics. One is Great Expectations. Well, firstly, it's an open source project, right? It's a platform. It's a framework on which you can build and use to express your notions, and so therefore it integrates directly into your existing infrastructure. And one of the things that I'm really passionate about is making sure that possibility of integrating everywhere that it's valuable to you to get data about your data is very easy. Next is expectations become a translation layer. And that's going to be very central for what I want to talk about today, because they compile these data-driven expectations compile directly to documentation. And because they're also tests, if your data changes, your documentation can immediately change or be updated to reflect the best understanding that you have of the data. They're also very extensible. And one of the things that we've done a lot of work on recently is making it easier for people to add domain-specific expectations. Things that capture their business rules or their agreements between each other in very precise ways, and extending the validation logic and also the translation logic, that documentation creation logic into it. And then this last one, this is the one that I want to talk about most today. So this notion that automated profilers embody checklists of questions, and that makes it possible to collaborate in new ways with other people, with data sets. Okay, so with that as the kind of initial background, I want to talk about what is a data asset. And I think this is a really diagnostic question. I love asking people this question because there's all kinds of different ways that you can think about it. And I want to propose a very particular one, which is a data asset is specifically a thing that lives in the intersection of data that you collect and your purpose in using that data. So there's all kinds of data that gets collected in the world, and probably somebody collected it for a particular reason, of course. The reason that you're using it may or may not be exactly the same as the original reason that it was collected. And furthermore, you don't just have to have a single purpose for using the same data. We in the examples for Great Expectations and the examples I'm going to use in a little bit, we use a data set a lot from New York City Taxi and Limousine Commission, their trip data. So this is a data set that records a record for every paid taxi ride in the city, different kinds of providers, yellow cabs, which is the medallion cabs, green, and so forth. And if given that data, there's all kinds of different things that you can ask. And so, for example, I was looking at this data. Actually, I wasn't even looking at the data. I was downloading the data into a local directory just to get ready for this talk. And I was sort of looking at how long it's taking, because these are big files, and for whatever reason they store them uncompressed on S3 to make it take a long time to move them. And what I noticed is that you can see the impact of COVID directly just in the file sizes, right? There's just fewer bytes of data required to describe all the taxi rides that happened in New York. So understanding the impact of COVID, that might be a purpose. Understanding the impact of Uber and Lyft ride sharing services in the New York City taxi environment, interesting purpose. Understanding a policy change or predicting the impact of a policy change, that might be another operational purpose. And the way that you look at the data may be different depending on what you're going to do with that. So moving on from that, I think it's also really important to note that data assets carry with them assumptions that are heritable, and that they kind of inherit, just like object-oriented programming objects inherit characteristics from their parents. So, for example, a couple of different types of very abstract types of data. One thing that I think it's really useful is it's actually very powerful for us to be able to start thinking about our expectations, even at this very high level, because then we can bring some of those expectations in as we look at more and more specific instances of that data and map those into specific purposes. And we can begin to refine our expectations, tighten them up more and more as we look at specific purposes, and so get more information ourselves about when we're surprised, which I think is usually the thing that's most valuable, is getting surprised by something. So, for example, event data, right? There's no hard disk in the universe that has the event data on it. There's lots and lots of different kind of types or instances of event data, and they share some things in common. They're temporal, right? They happen at some point in time. They're isolated, and they don't carry complete context, right? They're recording something that some sensor observed. They might get enriched as they move through data pipelines. We might add different features to them if we're going to prepare the data to run through an ML model and take some action on the basis of it. But you can contrast that with like another kind of broad category of data that with kudos to my colleague Don Hepner, I will call report data, i.e. data where you have added context. It represents a kind of joined context about a thing that's important, like an invoice, right? The event sending out an invoice might be part of the context for what it means to be an invoice. The reports aggregate a bunch of different data as well. So given this notion that data assets sort of inherit assumptions from their parents, let's think about, we've got this broad category event data, and this New York City taxi trip data that I talked about, that's a kind of event data. But even that doesn't really get at like what we're actually going to be looking at, because the taxi data, right, if I download it and look at it or access it directly in S3, I can look at it in a lot of different ways, right? I might say like, what is the average number of passengers in a taxi ride in New York City? Great question. Lots of purposes that I might have might be informed by knowing the answer to that question. And for that, I might be like looking at this New York City trip data as this all the currently available New York City taxi trip data. If I'm in a streaming context, by the way, it might be true that some of the data that I actually want to know about is not available to me at the time, right? Like I had a chance to look at it. I got to store some characteristic about the data, maybe compute this rolling mean, say, but then that event data just disappeared into the ether and it's gone now. That might be yet another kind. On the other hand, I might want to be able to look at this taxi trip data from a monthly lens, sort of looking at it differently, which is probably very useful if I want to think about changes over time or some of the purposes that we talked about, like COVID, impact of COVID. So fundamentally, it's event data. It's New York City taxi trip data, but it's being looked at through a particular lens. And there's lots of different lenses. They're all valid lenses. If I was to go and look up New York City taxi trip data in a catalog, that's a legitimate thing to do, right? If I'm trying to share data sets with my colleagues because I've created an enriched data set that uses a better way of geolocating records than someone else, I want people to know about that data set. I want them to be able to take advantage of it. And there's no singular right way to look at that data as I publish it. Okay, so this creates a really interesting characteristic, a really interesting sort of problem/opportunity for data. And it reminds me a lot about the kind of classic thing that just blew up physicists' minds. And I'm not going to pretend I understand all the details, but like there's this beautifully simple experiment that helped drive us towards a fundamentally different understanding of the world in the form of quantum mechanics, the double slit experiment. And what we sort of realized is attention at some very deep level influences the world we see. And so that's the thing that I think is critical when you're thinking about data quality. Attention is what makes a batch. So let's go back to that example of reports. So we talked about an invoice. Well, so what is a batch of invoices, right? And I think the most common answer is that it becomes a batch when you look at it. And so like think about this from the perspective of like what's one of the most common data quality scenarios that people find themselves in. So let's suppose I'm on an ML team that is responsible for predicting the severity of outages, right? In a complex system. Incidentally, that's what my sister does. It's fascinating. So I want to be able to look at a whole bunch of different data, maybe classify customers into different kinds of use patterns that have different kinds of impact from outages in underlying infrastructure, and produce a report, right? I produce that report, it becomes part of a dashboard. Now, a business decision maker, say, who's looking at that dashboard, maybe it's somebody in sales who wants to be able to think about how they're negotiating with a very large customer. For them, the batch of data is the state of the data at the time that they looked at it, right? Because that's what the data was. Now, critically, and actually, I think this is really cool about how Great Expectations works. Like, that's a very natural concept in Great Expectations, because it correlates really well with flowing data through a pipeline. Like, when I run a pipeline and go out and connect to a warehouse, the state of that warehouse at that time might actually just be the batch of data that I'm looking at. Now, in other times, the batch of data that I'm looking at might be tied directly to data, or excuse me, to like a time, like in the New York City taxi data, where the batches of data could well be months, right? Now, so we talked about this notion that the purpose of looking at data is really central to what the data actually is. And the purpose that you're using really should be and does drive the whole process of how we're looking at it. And so I'd suggest that there are these, I pick five here, five questions that we're kind of asking before we even look at the data. Like, what do I have? And I think this is really critical, in part because in many cases, when you're first starting a project, you don't actually have the best data for being able to answer the questions that you really have. And so you have to go out and get data. So, that said, you also start at some point. So there's this question: what data do I have? What is my purpose? What am I trying to do with it? So then that leads you to, what is my data asset here? Like, am I looking at event data, this very abstract thing? Am I looking at monthly New York City taxi trip data? And then, like, next question, we're going to come to this a little bit more, is like, what is my exploratory data analysis workflow? Like, what are the questions that I want to ask? Like, am I interested in looking at the quantiles of this data? Am I interested in looking for outliers? Am I just interested in sort of understanding it overall because I'm engaged in a process of considering feature selection, or I want to avoid large correlations in features that I'm going to propose to a model, or I have some other concern about the assumptions of a model that I want to apply? All those questions then drive us towards the notion that whatever your answers are, because they're going to be different, it should be easy to work from. And not only will they be different, like, they'll change over time, because you're going to get new data, and you want to be able to say, all right, I've got new data. I've got a new data set that I can work with. And maybe it's event data. Maybe it's even New York City taxi trip data. Maybe it's just the new month, or maybe it's for a different carrier because they started reporting, limousine data in the same way that they were reporting medallion cab data. And you want to be able to keep all the rest of your work, right? You want this durable data discovery. You want to not have to start from scratch and do this huge project in order to be able to pick up and keep using the insights that you've gained about a data set. So premise here, it should be easy to work no matter what your answer is. So, all right, let's dive in. Let's do a little bit of live demo. I always have to sort of hope things go well,
pray.
Yeah, pray, exactly right.
Pray.
Like, pray to the demo gods. We're gonna do a real demo here. Quick hint, you have to get your hands dirty to define a batch. Why? Because it really depends a lot about what your data is. So let me take a look. If I look at, so I like I said, just yesterday, I downloaded a bunch of this New York City taxi data, which I grabbed just straight from S3, and they conveniently put a space in the name for me. So, all right, here's what we've got. We've got these different kinds of data, you know, FHV, F8, whatever. I don't even know what FHVHV is. Green data, and then the one that I usually like to work with is yellow cab. This is kind of the standard yellow cab data. And you'll notice it comes in already conveniently from New York City in these monthly files. So what we're going to do is we're going to, let's see where we are. Let's actually just really go crazy here. We're going to run Great Expectations. And we're going to use our new V3 API, which very soon is going to be the default. You wouldn't have to type this anymore because it offers a lot of useful features around these kinds of things, like helping you to define a batch. Okay, so we're going to, first off, we're going to basically just sort of scaffold our, I'm going to cancel that because I didn't actually go into my clean, I didn't go into my new clean demo directory. And I want to actually be true to my form here. So, okay, so we're gonna go ahead, and we've just created basically a scaffolded project. Like we're zero investment in so far. And all right, we want to add a new data source. So we can just run our data source new, and we'll say, all right, for this, in this case, I've already pulled the data down locally, so I'm just going to grab it with files on a file system, and I'm going to use pandas to process them. And we just looked that this data is in opt data taxi and limousine. And this is going to now open up for us a new notebook that we can use to go through the process of telling Great Expectations how we are looking at this data. So let's call this New York City Taxi. And we got a delightfully weird path here, but we'll grab this is our base directory, this kind of trip data. And I'm actually gonna kind of start off by kind of leaving things as they would come out of the box. So we've got this configuration where we're saying, all right, I want Great Expectations. I want you to help me infer the different data assets that are available to me. And I haven't really done anything else at this point. I've just said, whatever you see, let's call it a data asset. And I can test that out, and I can see, all right, so what does it see? It sees, if I want to look at the world this way, I have 356 different data assets. Well, obviously that's not quite right. Each of these is not their own asset with just one batch in it. I want to think about this in a more hierarchical way, like we were talking about. I want to have, say, my yellow trip data be a data asset with a bunch of different monthly batches in it. So we can go back up here and we can say, all right, well, we know that the way the New York City data is formed, they actually use a particular naming convention for their files, which common. It could be if we're in a database environment, it might be some query with parameters in it. That's the way that we define this. Might be the table name. Table name might be already good to go. But in our case, we know that we have this convention where they, we saw they had like yellow. Let's see, where was our names here? Yellow _ trip data _ year month. All right, so I think we can probably recreate that. I can move my little zoom bar. So we're going to put these little capture groups year, month, and let's just give this a shot and see what we see when we look at the world sort of this way. All right, so when we look at the world this way, we see, all right, now we got 3 different data assets, FHV, FHV, and yellow. So perfect, just what we expected. We have pretty unusual batches. Like these clearly aren't the batches. Well, it's because in the fit of demo, I forgot to actually say that these represent year and month, which are just names. Well, let's see if we add that information. All right, now we see, all right, each of these are now starting to represent different batches. And notably, there's a bunch of data that didn't match because I just compressed all the green data. So it's not matching our regex, and could write a different regex to handle those as well if we wanted to. All right, so let's go ahead and save that and take a look at what we just did. So we added a clean demo great expectations directory. In here, we just added this new configuration where we've got this year, month, and day. And now I did prepare just a quick notebook that we can take a look at for running through what we've sort of check in what we've done. All right, so we've now got a data source. We can create an expectation suite as we usually would. And looking in here, we have this data source is called New York City Taxi. We've got a trip data monthly data connector. Yellow is our asset. And each of these batches have different characteristics. Like we have a batch for 2013 month 1, right? Now, like there's nothing sort of magical at all about what we've done. All we've done is add purpose, like add our intent into how we want to look at a bunch of data on our file system. Now, why is that so important? That's what we're going to come to in a second. So let me come back and say, all right, yay, we have a batch, right? Like there's data out there, and not just that, like this data is now sort of primed for how we want to look at it. And we're going to be able to do some interesting things with that. So exploratory data analysis is all about asking questions. Like, what does my data look like? What columns does it have? Maybe I'm going to ask, what are its quantiles? Does it match a regex? Does it have null values? Any of these kinds of questions. These are the questions that I want to ask about the data. Now, why are we looking at why is it so important at this point, again, that we're looking at the data in a particular batch? Because quantiles may be different month to month. It's the monthly quantiles that we're caring about. Like if we look at the row counts, for example, one of the kind of best ways to catch the classic data went missing problem, that matters for what your delivery cadence is. In that case, delivery might be batch. So we want to be able to ask these questions. And specifically, we want to do that in a way that avoids the cutting room floor, right? The problem, which I just grabbed this straight off of the MLOps website, MLOps.org website, because I think this is just like tells a really classic picture. You do all this work, you build this amazing, fancy, phenomenal model. It's powerful, it's predictive. The world happens. Performance degrades. You go through a new training cycle. Wash, rinse, repeat. The thing is, eventually, you're not the one doing that anymore. And the information in your head that you're using to update your model, right? Because it's likely that you're going to want to make changes that are beyond a simple retrain, but maybe also involve changes to architecture or features. When you're doing that, you're using your knowledge of the data set. You're using your knowledge of the data available to you, the purpose that you're using it for, that intersection. So we want to make it easy to keep that. So the way we do that in Great Expectations is a framework for defining custom workflows for exploring your data. So instead of just sitting down at a notebook, and between 10 years ago and now, there's been phenomenal innovation, and my notebook is shared and versioned and stored, and like we can do way, way better than we could before at sharing, templated notebooks and so forth. That does a lot. Actually, I'm a huge fan of that for being able to make the processes that you go through to understand a data set more discoverable. But even then, it's not as easy. We don't have like these composable units like a workflow system that can really offer for capturing the process of doing data discovery. So that's what profilers give us. They're this like admittedly very verbose in classic GE way, but powerful as a result. I mean, this is like the toolbox version. The configuration-driven framework where you can customize different features of rules. Now, these are not rules like this data must look like that thing, right? These are not expectations. These are ways of creating expectations by looking at data. And you don't have to just look at one batch of data, right? So now that we've gone through this huge amount of energy of defining batches, like let's take max and min, right? Expressing anomaly detection, right? Like, all the things that get marketers excited, expressing that becomes a very simple rule, right? Like look at the data for the last 5-10 batches or the first 5-10 batches, say. Look at the ranges that we observed for min value, max value. What we do in our case is we use this, of course it's great expectation. We had to use a ridiculously long name. So we use the multi-batch bootstrapped metric distribution parameter builder in order to say, all right, let's take a bunch of batches of data, right? For each of those batches of data, let's look at the observed value of some statistic, mean value, right? Then let's run a bootstrapping procedure to estimate how, what are our confidence intervals around, say, in order to create like an estimated 1% false positive rate around values that we observe. And let's use those as a starting point for our expectations. Because of that, they're very reusable, right? Like so the entirety of expressing this anomaly detection system becomes just a couple of lines, and it's not like some black box system, right? You can change your alert threshold to be whatever you'd like. And not only that, when you change it, you're sort of showing everyone what your thinking was around how you wanted to explore and understand this data better. All right. So
wait, can I jump in there and ask you something real fast?
Yeah.
Because this is fascinating to me. Like basically are you just getting rid of the need for comments and kind of leaving breadcrumbs around this? You're showing that when someone is working with great expectations, others should be able to pick up on what they were trying to accomplish intuitively.
Exactly right.
Wow, okay.
If I go back to 4 years ago when the very first kind of big public demo of Great Expectations, we sat down at a notebook and went through a process of building an ML model, observing exactly the phenomenon that you always see, the model quality eroded over time, and then being able to ask the question, why, right? Like, it's easy for me to just say, okay, well, model quality degraded, I'm just going to retrain on the most recent month's data. But like, why? Like, what about the world is changing that is causing me to need to do this? And at the time, I think it was great what we did, right? Because it helped share what you were doing. But at the end of the day, it was still just a notebook, right? It was still me interacting with the data and saying, well, what is the distribution of this column? What is the distribution of that column? But now we're going way past that. Now we're saying, what is the workflow you want to do? You want to ask the question, what is the distribution of all the numeric columns? Done, right? That process of asking and answering questions gets encapsulated into a rule. So you say, ask this question of the data, go compute the mean over the last 5 batches, do the statistic, right? Ask that question. What is the range of mean values that probably covers 95% of the batches, and come back and put an expectation around that. Let me show, hopefully it's going to be even better if I show you sort of what it actually looks like.
Yeah, let's see it. It's super cool, man. Very cool.
So let's say, we don't need to show all the stuff. This is kind of the classic way of interacting. The classic way of interacting with great expectations, you make an expectation, right? Like, I expect this, the framework gives you this response like, oh, you know what, actually that's not what we see in the data. So maybe you need to update your expectation. That's the old way. Now all of that gets encapsulated in the process, in the concept of the profiler. Sorry, let me switch over here and pull up this profiler that I built here as our example. So in this profiler, firstly, I can define sort of variables like what is the false positive rate that I'm going to work with, how much data from each batch I want to work with. I can build different kinds of batch requests, right? So now that I've kind of taught great expectations how I'm thinking about my data, not just here's the data, right? But like, here's how I want to think about it. I want to think about it as monthly batches. I can do things like, all right, here I want to look at the first 5 batches. In this query, I want to be looking at the first 3 batches. Here, I just want to look at 1 batch. And what I want to look at is going to be relevant, different kinds of questions that I have. Sometimes I'm going to want to look at a bunch of batches of data to answer that question. Sometimes I might only need to look at 1. And then I can write rules, right? So I can write the schema rule, for example, in which I say, really simple. What columns are available? And I want to set an expectation that the columns that I observe will match. So I've run this, and here is what we get when we run this. Right, we get, to start off, you just get an expectation sweep. So the result of a run of a profiler is a set of expectations, right? It's like the output from all your rules. And, we can look at these and, we see, just the kind of things that we talked about, right? Like, we see this, latitude is probably not a particularly interesting one to look at as numeric data. But we can sort of look at the output from the profiler, look at what it has observed and say, all right, so, I looked at the data and I said that I expect there to be exactly 10,000 rows. Well, in this case, that's just because, I picked 10,000 as my arbitrary number of rows to look at. And I expect it to have thus and such set of columns. And it looks like my browser is freezing on me. I think. Weird. But let me just scroll around here a little bit. So what were we going to look at? Surcharges. It's actually local, so I don't know why my page got unresponsive. But we can look for a second here at just the kind of raw results, right? So at this point, we're not actually looking at any particular validation. We're not comparing anything. We're just basically kind of looking at the answers to all of the questions that we asked. I'm going to just click over here. If I pause that and I kind of now switch, and I say, all right, now I want to look at the result of a validation. And in this case, what I've done is I trained on, or trained is overly ML term. I informed my expectations initially on the basis of like the original batch of data. And then I just like curious, all right, let me run it against this like most recent batch of data. And, I promise, I actually ran this last night, which is, embarrassing, but whatever it is, what it is, that's when I ran it because I was curious. And in fact, the classic thing is true, like I didn't know this, the New York City taxi data, they changed the names of their columns between like the initial month's batches and the later month's batches, like, classic. So, they used to call it whatever rate code, and now it's capital R, rate code ID, like, okay, I'm sure there's some great reason. I'm sure it's documented it somewhere. Well, here's where that documentation is auto-generated for someone. Like, oh, older batches should have this characteristic. Now it's very easy for me to say newer batches. Oh, you have different column names, right? You may have the same distribution of values and so forth, but it's very easy for me to jump in and zero in on any kinds of changes, because it's just as simple as like running this rule.
Could you make it a little bit bigger?
Yeah. Well, I can't unless I keep crashing my browser.
Oh yeah, that's all right.
Hang on.
There we go.
Oh, there it goes, nice and fast. So in this case, again, like just to show whoa, now it got very big.
Classic.
Oh my gosh. I didn't pray fervently enough to demo gods. Actually, Apple's telling me to go buy a new MacBook. Anyway, yeah, so here's an example where we have kind of the classic, data docs, we call it, setup, where we're doing a before after comparison. Again, we should probably scroll down and look at something where there is still a value. And this looks like a fun one. Fair amount. So when we looked at the data originally, we looked at 5 batches or so of the first 5 months of data, and we like the minimum fare we estimated should be in that $3 to $4 range. Somehow somebody in the universe got a negative $52 fare riding a cab. Now I want to figure out how they did that. I actually really, that sounds delightful. Similarly, the max value of fares, like we guessed based on the first 5 data, like, oh yeah, it looks like people, most people pay is between 50 and 70 bucks. Well, no, somebody got a big bill. Now, again, like the beauty here is like how quick we're getting to the story, to not just the story. Like there's no right story. Like these are the things that we're going to dig into. You want to get in the business of data quality. Like you need to know your data. I would not have guessed that fare could be negative. I'm again curious why. It's possible that we have data entry. It's possible they're doing a massaging. It's possible that that represents the total fare after some credit. I don't actually know, but like that's the beauty, right? The beauty is that I don't know yet, but that I can immediately add new expectations about that going in the future. Now, like let's suppose, for example, that I'm in MLOps, right? And my job is to take this raw data, go out and get it from New York City and build a model for my new ride hailing service where we can sort of estimate how much other people are paying and so help inform our profit and loss. Well, I'm probably going to now take this and be like, well, obviously, fair amount, maybe it's not obvious. Maybe I don't think fair amount should be allowed to be negative because it needs to be normalized in some way. So I'm now going to take the raw data, right? Do my transforms, run it through my kind of initial pipeline. And then I can run either these same or a new set of expectations against the transformed data in order to really understand like what I've got at this point. Make sure that after all my transforms, it meets the expectations that I have. So I've checked the data first when it came in, and the world is dynamic, especially when you're dealing with external vendors or a complex collection system. Like the world will change. Somebody's going to, charge negative dollars to ride their cabs. All right. When you find that, it's all a question of what you're doing then and how you update your expectations, both there and downstream. All right, I went long. I know I went long, and we haven't paused for more questions. Let me kind of pause there, stop there, and figure out where you want to go.
Dude, first of all, this was awesome. I told you I was going to give you a few softball questions because you got a concussion 2 weeks ago. And I think the main question that I have, and this is one that I sourced from the community, some people were asking me to ask you this on here. It's what's the role of a data scientist using grade expectations in an MLOps setting? And I feel like you touched on it just there at the end a little bit, but maybe I can see how this can be very useful for a data engineer, ML engineer, or a data scientist. Like, how do you see the person that you like market this towards?
Yeah. So firstly, I think there's not like one right profile of the person that gets a lot of value out of using grade expectations. For the data scientist in particular, I think, well, actually, let me say, even a data scientist, I think, is probably in their role interacting with different constituents. One of those are people with whom they're sharing, models or raw data. For that case, I think it's actually kind of a very classic use for grade expectations, because it allows you to, like we were just talking about, kind of package your assumptions along with what you're sharing and then share that further. For the constituency where like your output is kind of an answer to a question, maybe my like, how much revenue did we lose from cabs specifically because of COVID? All right. And as a data scientist, my job is to disambiguate the impact of COVID from the impact of Uber and Lyft, which potentially had already been having a significant impact on like the macro trend. Right. So I'm trying to disentangle these two things. Like, both things are happening in the world at the same time. Grade expectations helps me because I can get into my data and really tease out all of the assumptions that I have before I begin my process of modeling those two interacting forces and understanding then like what the actual answer to our questions, like what we're already looking at, like what was the relative impact of those two things.
Yeah.
And again, really, like, it also helps just from a straight quality. I never want to get, I think I sometimes forget like just how much pain people feel, or not, I don't forget, but like we don't talk enough about like just how much pain people feel from just quality issues. Like, data scientists, like, you need to feel confident that the data you're looking at actually means what you think it means. Again, if I went and looked at fair amount, I would have not guessed that could mean a negative number.
Yeah, completely. So good, man. I appreciate this so much. I know that we are running up on time. If you've got a minute extra, I want to ask you one more question. Do you?
Sure.
Can we? Yeah. Can I shoot?
Yeah, we get.
So
yeah,
like two things come to mind, and this is very, I guess, vendor specific, and also a lot of people out there are trying to figure out the different areas that companies play in. And I've had the folks from Arise AI on here before. I've had the folks from Monte Carlo on here before. I've seen like Soda. Where do you feel like you differentiate between those? I know that you are, out of all of those, you're the only, Great Expectations is the only open source project, but I imagine there's other things. Is it this whole way of thinking and this workflow that you're trying to push? Is that one of like the huge differentiating factors?
I really think it is. Yeah, I think you're exactly right. I think, with Great Expectations, we're really trying to keep the emphasis on your ability to understand and communicate about data. And in order to make that possible, in order to make that effective, we have to make sure there's no element of like black box data quality. We're now at the same time, of course, we want to make sure that you're not having to, write 10,000 rules or something like that, or, rules is not right? Write 10,000 expectations individually. So we're really focused on enhancing your understanding, like your deeper understanding of the data, and then facilitating that between different people. I will say there's also another element that I think is just important as a differentiator, which is when you think about like who wants to adopt great expectations, what we find a lot is that it really, really resonates with people who are feeling the pain of getting the call today of data quality issues. And so we're like, and that gets right to the heart of being an open source project. Like we're very much focused on maintaining our like developer first approach to this field. And we really, it's not what we're talking about today, but we're putting a lot of energy in trying to help make it easier for people to contribute to the project, and to add these profiles, like, right. So, you look at what I just showed. I mean, hopefully it's clear where we're going with that is, I don't need to be the only one writing these rules, right? I don't need to be the only one writing these parameter builders. Like we can create a community of people who share their best practices around how you even want to guess what an anomaly is or describe an anomaly, right? We don't need to have there just be 2 or 3 people telling you that. So we're really trying to unlock this broader engagement of a community to both both improve the platform, but also, almost like add apps or add these capabilities on top of great expectations that are informed by their domain knowledge, by their specific expertise, by the practice that they're seeing.
Awesome. Well, thank you for coming on here. Thank you for sharing this with us. I will reiterate that if someone wants to get involved with the Great Expectations project, jump on over into your Slack, I imagine.
Yep,
I don't
absolutely.
know if you can hear the concert that I've got going on right now in the background. It's about bedtime right now in Germany. But the other thing that I will mention is, you guys are hiring. So go and work for James and the awesome project that you're doing. And if you're watching this in the future, give us a like, give us a subscribe, leave a comment, whatever you feel moved to do. We would really appreciate it. Thank you, James. This has been awesome, man. I really appreciate the time you took and the demo. It was cool. And I like learning about this, like really, really liked the way that you approach it and this whole workflow mentality and setting expectations, setting the right kind of expectations. It's really awesome to see.
Thank you so much. My pleasure.
See y'all.
Everybody.